In the chat, a bunch of people have introduced themselves, which is great. Could you mention like what software tools do you usually use for your data-oriented stuff? I don't want to be too prescriptive. Like whether it's data management, data analysis. Do you use Excel a lot? SPSS, R? I want to get a sense for the room. Like, what's the most popular thing or popular set of things? And this is like arbitrary. You don't have to pick from this list. You could say like Tableau, MATLAB. There's a wide open universe. I'm going to keep an eye on chat. Bunch of Excels, SAS and SPSS, some Stata, a little bit of Stata. Ooh, some more Stata's popping up. Power BI. Ooh, there we go. Tableau. All right, cool, cool, cool. All right. Oh, this is awesome. There is a huge array of software that's represented. The spectrum that I've put up on screen doesn't like exist in any formal sense, but hopefully it illustrates for you like where some of these tools might exist with relation to others, if you weren't already thinking about it that way. Microsoft Excel is like the perfect example of a purpose-built tool. It's good for managing tables of data, and that's it. Like you can do some descriptive analysis, you can do some nifty analytic things, but it takes quite a bit of work. And like the more advanced you get, the less and less suited Microsoft Excel is. Moving along to the far other end of the spectrum, what we're going to do today, Python is the opposite. So Microsoft Excel, including SAS and SPSS and Stata, you just open those programs right away and you can start using them, assuming you understand like what buttons to click, what to type in, where. Um, they're like purpose built for a clear defined purpose. Python is a general purpose programming language. It's a very wide open universe. So one of the challenges that we have to grapple with today, and I'm prescribing the solution to you, but you may find other things in the future. Uh, Python can do all of this stuff, and everything we do today you can do in Excel. That's on purpose. That way you have a grounded understanding of what you're seeing on screen. But in order to make Python work as a data analyst, a machine learning researcher, whatever, you need to bring in some other module, or I mean, you can write the code from scratch if you have all the time in the world. But for many people, the sweet sauce is searching for modules and packages and the tools that get added to the Python core that then allow you to do data analysis efficiently, quickly, and reliably. So that's kind of the framing that I wanted to use for this next slide. In the workshop announcement, one of the emails Tyler sent out, there were directions that if you wanted to follow along in a hands-on way during the session today, Anaconda is the program you need to download and install. If you haven't done that, don't worry about it. Just like watch, listen, hang out in the workshop. That's absolutely fine. You can still get a lot out of it, and then come back to it later on, install Anaconda on your computer, and start making your way through. Now, the reason Anaconda is my tool of choice in this case, one, it's extremely popular. Lots of data analysts use it. It's free, unless you're using it for like corporate enterprise level stuff. As an individual, it's totally free. And what it does is it bundles Python, the programming language, and the compiler and all that stuff, and adds and brings with it all of the, well, not all, most of the third party packages and modules that are extremely useful and overwhelmingly popular for like data driven work in a Python environment. The heavy lifters today are going to be Jupyter and Pandas. Jupyter is the interface that allows us to interact with the code in a relatively neat and tidy way. And Pandas is a module for literally working with tables of data, getting descriptive statistics, subsetting, and all that kind of stuff. Next week, we'll go into some other modules for like statistical modeling, and then the things that are on screen, Seaborn, Matplotlib, those are like visualization packages. The next slide, this is just a link. If you're wanting to install it and you haven't already, let me copy, paste that into the chat. There we go. If you want to try to rush along, you can like go there, download, install. But my advice is like, don't worry about it. Just watch and ask questions along the way, knowing that this is being recorded. So next slide, like why? I said earlier, like SPSS, Stata, like Excel, you just open the programs. Now they do have like third-party plugins and add-ons, but for the most part, you can just start using their core functionality right away. With Python, for a data-driven task, let's say you want to open a CSV file, just a very common data type, in the base Python set of like commands and packages and tools, the example screenshot that I have on screen comes from the official Python documentation website, and it's well, 1, 2, 3, 4, 5 lines of code just to open a CSV file. And if you look at it and you're new to this kind of stuff, it might be very overwhelming. There's a lot of different moving parts. And I said this was not an introduction to programming. There's a lot of different moving parts in here that are on their own sometimes weird to understand. Conversely, if we know about a module in the Python development community, in this case Pandas, it's 2 lines of code that does the exact same thing and in a more sustainable way. You import the tool Pandas, and we'll talk our way through that code here in a second. And then you tell Pandas, hey, read the CSV file, and then poof, you're done. So it makes our life a lot easier if you can identify these modules and packages that do exactly what you want in a way that is reliable. So that's kind of like why we're taking this approach, just to like get up and running as quickly as we can. The next couple slides, we'll come back to these, but like I said at the end, there's a bunch of slides with just different links. And if we need to, contact me afterwards. Like if you're struggling to get stuff installed, I have to prioritize Georgia State University students and faculty, but I'm also a public servant to a certain extent. Don't hesitate to reach out to me if you're having problems, if you need troubleshooting. I'll at least send you some links or some guides that might supplement what we do today. Okay, with all of that out of the way, before we start doing like the more hands-on stuff, are there any questions? Have any questions come into chat? And feel free to like put questions in chat as we go along, and I'll occasionally like pop over and answer them, um, and focus in on them. Oh, that's great. That's a great question, Jill. Are there concerns about the existing modules having errors? Can you assume they compute correctly, for example? No, you cannot make that assumption. These are still tools developed by other people. Now, there is a preponderance of evidence that, like, everybody under the sun, of Python data driven tasks, Pandas is the most popular tool. It's extremely well supported. You can find thousands of posts on Stack Overflow troubleshooting problems. You'll also find lots of GitHub forums where people are saying, hey, the latest version of Pandas, when you do this thing, it calculates it wrong. And one of the developers will see it, iterate, fix it. It's a dynamic community. It is the cost of free, though. So you do have to do a little bit of like critical thinking to make sure like you are getting the output you expect. And you can do that in a variety of ways. You could use multiple packages, one package to compute an average, another package to compute an average. That's a very simplistic example. But assuming the numbers come out the same, then you could assume like, okay, this is doing what I expect it to do. The packages I'm showing you in these workshops are extremely high repeat. They're very robust, very reliable. There's a huge development community and lots of people use them, which is evidence that like these are good and reliable tools. You might have in the future some weird third-party package that like only 2 people have ever used. That's when you need to start being skeptical and critical when you analyze whether or not these tools can be used. Great question. We downloaded Jupyter, not Pandas. Oh, don't worry. If you downloaded Anaconda, then it's all in the same. It's all taken care of, and I'm going to walk through it, and you can just watch what I'm doing and follow along. And if it seems like way off base, you'll at least know like, oh, I need to arrive at these other outcomes to mimic exactly what he was doing. Okay, let's get started. I'm going to minimize my presentation, and you can all look at my very exciting desktop. So first thing I'm going to do, I'm going to click my start button, and I'm going to type in Anaconda Navigator. There's a variety of ways to open Anaconda. It's a multifaceted program. But what I want you to do, if you're following along, open Anaconda Navigator. I'm going to hit enter. By the way, I am using a Windows PC. I am not super familiar with Macs, so I don't always know what the commands are or what the steps will be. So just a heads up. All right. So I've got Anaconda Navigator open. It like a bunch of things may have flashed on screen as it was getting booted up and started, but now I'm here. And there's a bunch of stuff that you can do with this Anaconda program that manages all of these things together. The thing that we're going to use the most is here, this Jupyter Lab. Jupyter Notebook is literally the same tool, but an older interface, a less friendly interface, I think. Um, but it's still stable, it's still supported, and lots of people still use it, so it exists. But the thing that I want to use today is Jupyter Lab. So if you are here, go ahead and click on Launch. So it opens my web browser. It opens the last thing that I had open, which probably isn't what you have on your screen. Don't worry about it. I'm going to close this. Okay. So those of you following along, quick yes, no, thumbs up, thumbs down. Are you on this screen? Have you made it here? You opened Anaconda. Okay, cool. Yeah, I just do these sanity checks because I don't want people to get lost if you are following along. And like depending on your computer, it may take a little bit longer to get Anaconda installed and opened, and then launch Jupyter. This is your starting point. Um, Lillian, I'll talk a little bit more, but I see enough yeses that I'm going to keep going. I'm not doing anything too exciting just yet. So, what I want to do, this over here on the left, this is like your actual file directory for your computer. This is your user directory, if that matters in a technical sense to you. So I'm going to close out of that, or I'm going to close the annotations. I'm going to click on my downloads folder. And downloads, let me make my browser a little bit smaller. Let me minimize Anaconda. Just doing some Windows management, basically. The most exciting thing you could do for a workshop, right? So here I've got the same thing. So in my computer, I've got my, this would be Finder in Mac, File Explorer in Windows. I've saved today's workshop files that I think you should have attached to this workshop, or if you need to, I can post a link and you can download the files again right now. But these files are the same files that we're seeing in this navigator over here in Jupyter. So what happens in Vegas stays in Vegas, but what's important to know is the things that happen here in Jupyter Lab are actually happening on your computer. All right. That's something that trips people up the first time they use the Jupyter interface. So I'm going to close out of these annotations. I'm going to make my screen big again. So what, oh, actually, no, I won't. Now here's another thing. If you're having trouble, because what I did here in Jupyter was I found, and this is what you should do, I tried to navigate my way to the folder that contains the stuff that I want to use. If that doesn't work for you, like if you can't find that folder, if you don't know where it is, this is where Jupyter Lab is kind of cool. You can just drag and drop. So like if I click on a thing, I can drag and drop and move it into that folder, whatever folder I happen to be working on in Jupyter Lab. What I'm going to do now, so I've got this frame here. What I want you to do, if you've opened Anaconda, you've opened a Jupyter Lab, you've navigated to a folder. What I want you to do, don't worry about any of the stuff that's here on the left. Click on Python 3 under Notebook. Ooh, let me draw it like, click this button or double click it, and that's going to open the very first thing that we're going to work with today is this Jupyter interface. So now I have this blank tile. I have untitled IPYNB, which is a file type called IPython Notebook. We can come back to the technicals if you want. And that file is automatically created in my folder. Or a critical mass of people here. I just get a blank frame. I'm not sure what that means, Charles. If some of you are still trying to find the folder, I would say don't worry about it. Just what you can do by default, like wherever your Finder or your File Explorer has the file, just like have that and then drag and drop the things into whatever the working directory is you have for Jupyter Lab. Clicked on Jupyter Lab, it opens, IE with a blank frame. Internet Explorer does not play well with Jupyter Lab. I should have said that up front. So I'm using Google Chrome. I think Firefox works as well. I don't know about Edge. So you might copy paste that URL and switch browsers. Or you might need to change your default browser later on. A couple things to talk about. Up here, you have this little menu of like save, add a cell, whatever. The one to note is this little play sign here. That's one that you could click. This is going to be the button to execute your code, but there are going to be shortcuts that come into play. The next thing to understand is like this blue line tells you which cell of your code is currently highlighted. Right now, there's only the one cell, okay? And this is a cell-based like system. So for any given cell, we're going to put in code. We can put in huge amounts of code or tiny amounts of code. We're going to start with tiny amounts. And when we execute that, like the blue line indicates which cell is currently active. And if I run that line of code, that code is then sent to the Python compiler that's invisible to us in the background. And if there's an output, then we also see that displayed to us directly underneath in this environment. So let me close out of my annotations. I'm going to type in the number 17. Oh boy, it's not highlighting for me. Let me refresh the page, because what I should expect to see, let's do this now. Ah, there we go. If you weren't saying color coded, so 17 should be green. It's barely green. But I've typed in a number, and if I run that code by clicking the play sign, Python doesn't do anything exciting. We sent it the number 17, it looked at it and said, thanks, buddy. Got the number 17 and sent it right back. Now we could do more complex things, and we are going to do more complex things, but this is the core of how Jupyter Notebooks works. In the cell, we have put in a command, we executed the code, clicking the play sign, and we got an output. Now, you don't always want to click that play sign, just like every other tool that you all mentioned, SPSS, Stata, and SAS are as well. There's shortcuts. So I'm going to type in 16 in this next cell, and I'm going to click on Run up here at the top. Oh, sorry, the menu went a little bit too fast. You can run the selected cells. You can run the selected cells and insert a new cell, or you can run the cells in place. These are the shortcuts: Shift-Enter, Alt-Enter, Control-Enter. By the way, you don't need to panic about taking notes about this stuff. Once we open the code file, all of this stuff is explicated out, or much of it is. So hopefully that guides you going forward. So we can play around with that real quick. Let me do, like on 16, I'm going to do Shift Enter, and it runs that cell, moves to the next line. If I type, if I want words, now I can do like math right away, like 16 plus 16, and I can start doing operations directly in here. This should, I think, give me 32. Shift, Enter, and I'll try to announce every time I do this when I execute a line of code. So now it's 16 plus 16, and I get a 32 out of it. All right. The other shortcuts, so Shift Enter is the one I will use the most. It runs a cell, it sends the command, we get the output right underneath it if there's an output to see, and then it moves to the next cell, or it creates a new cell if there isn't one there. Some of the other ones I'll do, let me click on further up here. So I've highlighted this second cell. If I do Alt-Enter, so the Alt key, Alt, Enter, it runs that line of code and inserts one in the middle. Another thing to keep track of, don't keep track of it, but it helps you keep your sanity when you start to try and figure out what order did I run my code in. These numbers indicate the order in which you ran this cell, then this cell, then this cell, then that cell. Usually, most sane people run the first cell all the way down. So 1, 2, 3, da, da, da. Like that's what you'll end up doing. But the nice thing about Jupyter is you can rerun individual cells as you continue to tweak your code, tweak your functions, make little changes, and then when you're ready, you can execute everything. But watch that number. This is the last little example that I have for this. Watch that number as I do Control Enter. So Control Enter once, Control Enter again, Control Enter. You see that blue line not moving? This is how I can continue to run this line of code. Hopefully that makes sense. Another thing to keep in mind, numbers you can do math with. Python does some strange things with strings, but I could put in 3 inside of quotes, and this becomes a string or a character or a word. In this case, it's referred to as a string. Shift, enter, and it gives me the output. Now, the important distinction to understand is like, let's put 3 in quotes plus 3 in quotes. If you add 3 and 3, you get 6. But if you add the word or the string 3 and the string 3 again, it actually just concatenates them. Or it might produce an error. So quoted 3 plus sign number 3. If I run this line of code, shift enter, now we start to get errors. And you're going to see lots of these errors as you start to like develop your Python code. If you have mismatched data types, you're going to start to run into challenges. And this is just a good indicator of like, oh, the data that I pulled from this source is encoded as a string, and I need to convert them all to number types, or maybe the reverse. Like if you have like survey data and you want to encode it as categorical, nominal, ordinal type levels, not necessarily their number value, you might go the other way. So like this is just a thing to keep in mind, and usually Jupyter does a good job of highlighting like numbers are green, strings are red, and it color codes different parts of our Python experience. That's just a flavor that's added to the Jupyter environment. That's one of the benefits of this. The last thing that I want to point out before we like open the code file and start to get serious, let me do Alt Enter. So up here, I've just issued a command. I've said 16 plus 16, go. And like, that's it. So Python looks at it, looks at the command, does what it's expected to do, and it gives me an output. But the core of what we need to do today is going to center around objects. Python's an object-oriented programming language. So we can create objects arbitrarily. That way we can like move them around, we can do stuff, we can take very big commands and succinctly represent them in a single variable. So on the easiest level, x equals 17. Okay, shift enter. I don't see an output. I ran that cell. I ran the cell x equals 17. I did shift enter. There's no output to do. All I've done is I've assigned the value 17 to the object x. Now to like get that value, I can type x by itself, shift enter. I can start doing operations, x plus 17 again. Oh, I should move my cursor. X plus 17, shift enter, 34. But x by itself is unchanged. This is a trivial example. It's super duper small, but it's going to be what allows us to build up more complicated stuff. One thing to note about object names is they are arbitrary. Harry Potter can be the name of an object, and I can give it a value of Samwise Gamgee, the real MVP. So if I do this, shift enter, I've now created an object called Harry Potter, and I've assigned it Samwise Gamgee. If you were to send me code and there's this mismatch, like I might struggle to read your code. I might struggle to interpret your results. My advice, make sure when you're creating these objects, give them meaningful names that represent the underlying object. Because when I do Harry Potter, Python doesn't care. Python doesn't know who Harry Potter is. It's just an arbitrary object I've created, where if I do shift enter, the value of that object is totally unrelated on a human conceptual level. And when other people start reading your code, or when you try to review your code, you'll do yourself some favors if you keep objects labeled in a way that is like generalized and makes sense and like effectively communicates what the underlying value might be. Those of you that have been able to like get Anaconda open, Jupyter Lab open, I know it's been a bit of a trial and tribulation. Some of you might have just gotten stuck and are just watching now, and that's okay. That's fine. Does everyone understand how to like? Those of you that have gotten this far, type in code, enter code, execute code, run a cell to have an input, then produce an output. Nothing here is rocket science, but this is like, I mean, it probably isn't rocket science, but it's the foundational stuff. A lot of yes, a lot of yeps. Mine's working now. Oh, okay, great. Glad you caught up. Sweet. Okay, so let's just do. I'm going to do this together. Untitled IPYNB. Right click, and I'm going to rename it and I'm gonna call this junk. This is junk. I'm not proud of this. Uh, and I can rename these files on the fly. And if I open File Explorer, we can now see like, here's my junk file. Like now, for me, this literally communicates to future versions of Jeremy Walker. You can just delete this file. None of this matters. Um, but I just wanted to make it clear, like this file now exists on your computer. If you write some beautiful code and you have beautiful outputs, or even just kind of like dodgy code and dodgy outputs, doesn't matter. You can take that file and exactly like what I've done to you, you can email that to a collaborator or to a colleague. They can load it up. They can open it up on their screen. They can see your code and your outputs, even if they don't have the underlying data set. Now, if they want to like rerun the code, if they want to re-execute, like rerun the regression, replot the data, then they do need the underlying data set and that kind of stuff. All right. So let's get into the good stuff now. Intro to Python. Let me make this window a bit larger. Intro to Python for data analysis. Double click on that, and this is the meat of what we're going to get through today. Everything else has been build up, introduction. This is where like we go through and we really start opening up some data. So I'm going to give everyone a chance to do that, assuming you have successfully like found that intro to Python for data analysis .ipynb, and you've drug that file into this area. You can then open it, just like double click on it, and that will open it on screen. And you should see like this stuff. Also, something that you need to have in this folder is the youth risk.csv. I see a lot of yeses. Okay, so I'm going to get moving. So I see a lot of annotations. So if I click around, like I have done things, I know how to do some markup in this environment to make things look pretty and use headers. There's guides on the internet if you want to replicate that. But what's important is that blue line is off to the side. These aren't code. This is just literally markup, just headings saying intro to Python, blah, blah, blah. Shift, enter, and I can still run it as if it's a line of code, but I mean, it's not code, it's just annotations. Shift, enter again. Here's a cell. This cell should look familiar. It has that cell structure, then it has stuff on the inside. What I've done, and I've tried to do this as robustly as possible, is I write comments and annotations from me to you, from me telling you what I'm doing with the code throughout the rest of this file. So we've got an hour and 15 minutes left. We may not get to the end. That's okay. These comments are interlaced throughout all of the commands, all of the examples, and hopefully they are a comparable supplement to like everything that I say today. So I won't be reading from it, but you can also write your own notes. Like I can put in hashtag or pound sign, depending on what you want to call it. And I can put in a note like Jeremy is insane. Like you could put a note to yourself. You could put whatever you want. This is a way for you to mark up and annotate, write notes to yourself, write notes to others. Whatever is appropriate. So you're going to see a lot of that throughout this workshop. And if I run this cell, shift enter, nothing happens. Like the little number to the left appeared, but all of this, like the Python compiler just ignores it. Okay. So now I'm just going to do like shift enter, like part 0. By the way, we just did part 0. That's what we did in the blank Jupyter notebook, which is shift enter, control enter. I give some examples. I'm going to keep scrolling down little by little. You don't need to like run any cells of code. And I talk through like doing some math operations, how strings appear, how different things add up. We've covered all of this, but it's there as a refresher for you for after today. I'm going to scroll way down, scroll to part 1. This is the real part, okay? So part 1, this is where we're going to start opening data. Now, I'm not going to read my own writing to you because I know nobody enjoys people reading from PowerPoints either. So this information's there for you going forward. I'm going to scroll down to this first little block of code that actually has some real code. Import pandas as PD, okay? This is the first thing that we need to do because I keep saying pandas is the tool we will use. Usually preceding a piece of code, what you'll see in some format or some way is some example syntax where I try to generalize what I'm doing. So it's import and import is a Python function. It's a reserved word. So Python package name as abbreviation. And as implemented in this case, it's import the pandas module as, and I'm like, we don't have to do this, but it's convention. So I want to show you these conventions. We give it a shorthand, we give it an abbreviation, something that's easy for us to remember, like PD will stand for the pandas module. So I should be able to run this line of code. And if I do shift enter, it might take a few seconds. Like this thing here might stay a star for a little while before turning into a number. If by the time I'm done talking, it's still a star, I would say like go up, refresh the page, or in the kernel menu, tell the kernel to restart Python or restart the kernel. Um, it's a common thing, like the first time you use Anaconda, just to like make sure everything gets connected correctly. Uh, but in my case, I ran the cell and it successfully imported pandas. Now the next cell, and like we're gonna start dissecting some of this stuff so it makes more sense. But finally, we're gonna get to some data. The function that I'm doing follows the syntax abbreviation, function, options. Okay, so the abbreviation for the module that I'm using, the function that we are calling upon. This a function, like if you're familiar with Stata, it would be like reg, which is a shorthand for regression. Um, or LM if you're familiar with R, LM for linear model. So pandas function something. And in this case, it's pandas. I happen to know there's a function called read CSV. We'll talk about how to find all this out later. And I'm going to, in quotes, put the name of the CSV file, like here, exactly as it appears in my working directory. And then when I run that line of code, I should get a snapshot of the data. And finally, after all that talking, after like 30 minutes of me running my mouth, we have finally used Python to open a CSV file. Okay? So, and all of that was literally 2 lines of code. I've talked a lot, but it's 2 lines of code. Import pandas as PD, using pandas, use the function read CSV, and inside the parentheses, that's how functions work, we tell it what CSV file to read, and now we get this output. What do we see? Somewhere further up in the code, I describe the data. I explain where it came from. This is sourced. I didn't make this up. This is from a CDC data source from, I think, like the early aughts, maybe like 2007. I don't know. There's a couple variables like females, probably pretty easy to note, zeros and ones. Like, okay, it's probably a male female indicator. Grade is like their grade. So like this is looking at youths, and it's about the risk, and we've got a dependent variable. Well, the target dependent variable of the original research was what is the likelihood that somebody like a youth, a teenager, will get in a car with a driver who is impaired by alcohol, like get in the car with a drunk driver. Um, and that's a 0-1. Yes, no, did they do it? And then like next week we'll do logistic regression. But then we get age, like does the respondent, does the person who got in the car, do they smoke and do they have a driver's license? This is the core data that we're working with. We've got some nans, like so. This is just a good way to like, okay, what am I dealing with? What's my data? The nans are missing values, so those are incomplete observations. That's like a null value. However you represent that. Oh, I see a question. Do the caps in the text file names matter? Absolutely. Python is very precise and very picky for a lot of those things. So because the original file name has capital Y, capital R, in this case, the capital Y, capital R really matters. There's a few like gimmicks and tricks that I'm going to show you to like auto-complete some of this stuff, so it's a little bit easier to do. But I just want to like get through the blunt version of this first. So one thing that appears is like this unnamed 0. And what that is like in our original CSV file, and actually you can just watch me. You don't have to do this. I'm going to double click on youth risk CSV. And there's actually a pretty decent CSV previewer in Jupyter. And I can see like, oh, here are my columns. I've got like right alcohol, female, gray, da da da. I also have this unlabeled column, which is like my row observations or my row ID or my sample ID. You might have data that does something different. In this case, it's just a running number. Like it's not a meaningful ID. So I don't want to preserve it. Or like maybe I want to use that as my index, which is a label, but it's not part of the data values per se. How do I do that? Let me go back to the code. And this is where we start expanding on what we've done. So if I scroll down, this next line of code, same deal. Pandas, read CSV. I have my thing, the thing that goes inside the function that I want the function to operate on, which in this case is the name of the file. And then I have comma. So the comma separates our options within a function. And I'm going to show you how to look up all these options later, I promise. But there's an option called index column, index col equals 0. So the 0th column, which Python starts counting at 0. So the first column or the 0th column, like use that as the index. So now if I run this line of code, shift, enter, now we're just down. The only columns we have that are the labeled columns we have are the true data values that we're interested in. Now, this by itself, not that useful. We're just running a command and it's pumping data out to us. Remember, we want to use objects. We want to assign this to a placeholder, an object, a variable that we can then use to transport and do other stuff with. Let me scroll down. Oh, by the way, pandas can open like SAS data, SPSS, data, lots of different types of files, spreadsheets, JSON files, HTML. Like Pandas has a lot of pre-built functionality that works really well. You can even tell Pandas to read from an SQL database. That's really like that's more complicated, but it's totally possible. So this is just me talking about some of those options. You'll need to explore them on your own, though. But going down, let's make an object out of it. DF is a common placeholder. It's a very like when you Google like I need help with pandas and you find someone giving examples, they're going to use DF as a shorthand for data frame. So it's arbitrary, but it's the arbitrary one we'll use. DF equals this whole command. So now it's not just the number 17, it's this whole command, PD read the CSV file and also include the function to relabel the index column. So I run all of that, shift enter, and now I have a DF object. So if I do shift enter on that, now I've got my data. One thing that I do want to point out, I said I was going to make things easy for you. So let's say you don't remember some of this stuff, like off the top of your head. By the way, that's not hypothetical. I don't remember most things. I know my module is called PD, and then like we'll build this upwards. This is here in the middle. PD dot. The dot has special power, and part 3 of this code really explains and expounds on how that kind of works. But a period in this case accesses like subroutines, sub operations, functions, classes, methods, da 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 stuff. All the power of pandas you access with this period. And now, like Jeremy Walker, I don't remember the name of the function entirely. Like maybe you won't remember, is there an underscore or not? Here's what we do. Watch me. First thing I'm going to do, if you're on a Mac, you have to hold the button down. This might be slow the very first time you ever do this, but I'm going to hit the tab button, TAB, right above caps lock on my keyboard. And that opens up, in my case, it might be slow for you. You might have to refresh the page. Because again, it's doing some complicated things in the background. But for me, it opens up all the stuff I can do in pandas. Now I can like remember most of the function. I remember it starts with read. So I'm just going to start typing R and then E, A, D. And now it's filtering down to the subset of things that match my search, like read from clipboard, read from Excel, read from HTML, da 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 da. CSV is what I want, so I can hit enter. Like, and it auto completes for me. It's a function, so I do need to do the rest. Here's another example. So I'll do shift open parentheses, and it auto completes close parentheses, and I can add some spaces. That's fine. Especially if you have complex file names, here's an example. Like I know there's a file name that I want to open. So I'm going to do shift, like I'm just going to start the quotes, and I'm going to hit tab again. And now it's like, okay, here's all the files that exist in the directory that's off to the left. Am I able to annotate without that disappearing? Yeah, there we go. So like all of this stuff, it's telling you like, well, here's what I see. It's over here. That could include folders. It could include all sorts of stuff. But let me exit out of the annotations. So now I can go like, and da 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 da. Aha, there we go. Youth risk, hit enter. And then it auto completes. And then the next part was I do like IND, like I don't remember the rest of the parameter. Again, hit tab and it will give you some options. Oh, there it is, index cold, enter. And this is how I build upwards. Like it's a little bit weird, but that tab key really does help you like discover like what are my options, what are my autocomplete availability tools. Sometimes it won't work. Sometimes, especially if you're using a brand new object and like the object is complex or weird, you might have hundreds of options, and that's where you need to like read a different guide or read the user guide or tutorial or the documentation for a function to start getting an idea of what things to look for. But once you have a little bit of a clue, you can build up from here. Do caps matter in text file names? I addressed that. Can you open an XLS file? Yep, that's with the read Excel function. What does df do? Df is literally, like, it's the same as saying x equals 17. Okay? It's arbitrary. So in this case, I'm saying like my object is going to be called df, and that's my arbitrary example is df equals the function that I want to write. In this case, it's a big complicated function that reads a CSV file, and we're assigning that output, like open the data, assign it to an object, and that's where like df comes into play. Where does this df object save at? Good question. It lives only in this environment, in this temporary Python experience. At the end of this workshop, at the end of the code, there is an example of like, okay, you've done all this work, you've opened df, and it's temporarily available in Python. Maybe you subset it, maybe you truncate it, maybe you do something with it, you transform it. When you have some new version of the data, you then have to export it intentionally. There's an opposite function of like read CSV. There's a function that says to CSV. So that can take an object and export it to a fixed file on your computer. And I think that's like the last section of this code. Do you keep holding down the tab button or just hit it once? I just hit it once. I think Mac users have to hold it down. Um, and if the tab button isn't showing up on your PC, I would have to spend some time working with you to troubleshoot it separately. I'm not sure what's going on. It could be an issue with the web browser. You might have to close Jupyter altogether, close Anaconda, restart it from scratch. There's like the first time you open it, there's a lot of things that initiate in a way that requires a reboot. For some people on some computers, it's an inconsistent experience. But you don't have to rely on that. It's just a functionality that exists on top of everything else that we showed today. How do you get to downloads folder? So up here, like if you're talking in Jupyter, you can click on, oh, this is in the way. There we go. Like this little icon here will take you to your root directory, or your user directory. And then if your computer's organized the way mine is, that's how you can then find your downloads, your documents, your pictures, stuff like that. Oh, someone mentioned something that is helpful. So like for the tab, this will be the last thing we talk about. PD dot you like there might be too much for you to be able to load all at once with tab. That's a good point. So it might help to type the first letter and then type tab and then get the pop-up. That might help in some cases. Oh, I didn't answer a question. How does DF operate similar to DF in R? Data frames as a form of organizing data, R uses them and Python pandas uses them. They operate very similarly, but there are some technical differences, and the programming languages are notably different. So the way you approach different functionality is different. So in this case, df is just a standalone arbitrary object. We could have called it data table. We could have called it something arbitrary in that regard. So let me keep going to part 2. So we have methods. Methods are like functions, but they come out of an object. And I explain that in more detail here in a second. But let's just start using some of them. That way you see what they do. So in this case, I've typed in, under part 2, descriptive statistics, I just have some explanatory text, shift enter, df dot head, open close parentheses. So we're just inspecting data, df dot head. My df object, if I remember, like I'm going to go up to the previous cell, type the letter df, shift enter. So here's the data. It shows me the top and the bottom, and it tells me like, I'm not showing you the middle because there's 13,000 observations. That's quite a few, at least for like if you're working in Excel. But if I scroll down, df.head is a method that gives us some utility. So shift enter, and now I just see the first 5 rows. Now, when we did pd.readCSV, like we put some options inside of the parentheses, we could do that all the time. For all sorts of methods and functions, we can override them. So df head, if I put in this number 3, shift enter, now I just get the first 3 rows. I could change this as well. I could change this to 30. Change it to whatever number you want. I would keep it less than 100 just for your sanity, but you don't have to. Do what you want. df.head parentheses, shift enter. And like that, now I'm starting to see, like, now I can view like the top 30 samples. And then like inspect it. Like this isn't descriptive. It's still just like looking at the data and doing a visual inspection. But now we have a ton of information. Now, one thing, my data is overflowing on my screen, probably on your screen too, if you did exactly what I did. Right click in the middle, like right click on that data, and I get this pop up. And then there's an option called Enable Scrolling Outputs. This is just a tool for working with the Jupyter environment. It's not like a Python thing per se. Enable Scrolling Outputs. If you click on that, it will then create this little window. It'll then like truncate the window so that you have this little scrolly bar, and you can keep very large outputs truncated so that it's easier to see like line by line of the code, cell by cell. But then we can also see the outputs within this window and scroll down if we need to. And again, the way I did that was right click, enable scrolling outputs. Or if you want to get rid of that, you can click disable scrolling outputs. And it only applies to this cell. Now, like I said, there's read CSV, there's to CSV. In this case, there's df.head from our data frame, from our data table. Look at the head, look at the top of the data. For any given function you can think of, there's almost always an opposite. So in this case, df.tail does the exact opposite. So it looks at the shift enter on this line of code, looks at the last 5 samples. Or we can always overwrite it. df.tail 7, shift enter. So now I see the last 7 rows. Easy peasy stuff. It's just a way to like start inspecting the data. We could also, if you're familiar with like codebook or the structure command in R, we can start looking at the data types. So we can do df.d types. These are just things I have memorized. You'll learn them over time. Don't worry. This isn't a method, so it doesn't have parentheses. Don't worry about it. Just leave it exactly as is. Shift, enter. And now I see like, okay, ride alk driver, like the driver is like binary, yes, no, are they riding with an alcohol impaired driver, is encoded as an integer 64, like a 64-bit integer, which is a very large data type for a 0, 1. Doesn't matter. We can like, and then we can start to inspect, and this would tell us things like if we're importing data from an unknown source in particular, this could be useful because now these are all in the language of pandas. You might have to look up the little list on the pandas website of like what are the data types. There's integers, there's floats. Floats have decimal points. That's the only distinction there. There's objects. Objects represent character strings. There's Boolean, true, false. Uh, there's these different types of data types, but this gives you a clue as to like where issues might arise in your data and what things you might want to inspect or convert or change. Again, this is all just like starting to explore exploratory data analysis. Scrolling down, like I'm going to keep showing a few more examples, then we're going to talk about how to understand some of this stuff. And then we're going to get into subsetting. df.sample, because like maybe you don't want the top, maybe you don't want the bottom, 13,000 samples. This gives me one random sample. Or I could do df.sample 2. I could put a number in there. Again, we're overriding the parameters and the defaults. So now every time I'm going to hit Control Enter quite a few times, but Control Enter, it gives me 2 random samples. Control Enter, 2 more random samples. I could get 20 random samples if I change it. Control Enter, and I see that the subset changes every time. This is just a fast way of saying like, okay, what's a quick little slice of the data and what's a sample from it. And if you have weights, by the way, if you know like you want to weight some sample observations more than others, you could add that in. You could weight the probability of any given observation appearing. What if you want a sustainable random sample? Like you want to randomly sample the same 100 people out of a data set. In computer land, there is no such thing as random for the most part. So you have to set a random seed. How do you do all this stuff? What are all these options? How did I magically know about the index column option? That's the next thing. This is like the next like core thing that you should understand in Python. This works in R, by the way, as well. Question mark and then the thing, whatever the thing is. So in this case, question mark and like my df object dot, then the method it's sample, shift enter. And let me right click, disable scrolling outputs. And in Python, I don't have to go to Google. I don't have to like search for the official documentation on their website, although I tend to do that. You can pull it up right here and you can see like, okay, df sample, here's my parentheses, here's my close parentheses. Let me use my annotation tool. So here's where the parentheses opens, here's where it closes, and then here are all of the options available to us. And then down here are the explanations of what those options are, what the defaults are, what we might want to override. This can be extremely important for like understanding like a function's doing something weird or it's not producing the right thing. Or if you're doing some advanced analytics and you're calculating a metric, but there's multiple ways to calculate the metric, it's possible that inside the function, there's a parameter, one of these options here, that you can change to be the version that you want. One thing I want to note, you don't need to do this, just watch my screen. I'm going to go to Google, pandas sample. All right. So the first result for me was like the correct one. This is the official documentation from the Pandas website. And this is exactly what you see. Like the same thing that we saw in the help documentation in Python in that Jupyter environment. In this case, it's a very good module. They've designed their website in such a way that the documentation here perfectly mirrors the version of Pandas that you're using in Jupyter. Now, if you're using an older version of Pandas, you want to navigate their website to use an older, like one of their older references. Generally speaking, it's not that big of a deal. And this gives you the idea of like, okay, if I do the thing, here's the defaults of the thing, and here's what each of those things means. Last thing I want to point out, if you scroll to the bottom, way to the bottom, there's examples. A good module, good documentation in a Python world, like one of those like critical thinking things to look for is like, do I want to use this module? Is do they give good examples? Do they clearly say like, if you do this, you get this. If you do this, like this example with these options, you get this output. So like it's just something to look for, and you can see these examples. You could copy paste these examples into your code and then modify them. That's a very common approach. But it's just something that's there, and Pandas is exceptionally good at giving tons of examples. So that's how, like, when I keep saying, like, I know there's an option, Like, that's because I, Jeremy Walker, live and breathe in these environments and I start to memorize them over time. But when you're new, when you don't know, use like question mark thing and then like start reading the documentation. Make sure you understand what tool you're using. So I'm going to right click, enable scrolling outputs. That way it's truncated. Moving down a little bit, there's another method I happen to know. Let's have some fun. DF describe, because all we've done is actually look at raw data. Now we're going to start to get some summaries. So df dot describe parentheses. We'll just leave it at the default. Shift enter, and now I get some descriptive statistics. What is missing? This is a fun little check in the chat. Is there something that's missing from here that you think needs to be included? Or is there something that isn't being reported correctly or what you think would be correct? Python did exactly what I told it to do, so Python hasn't made an error in a technical sense. But from an analytics sense, like a troubleshooting sense, what's missing or what's wrong or what other things do you want? I see someone has mentioned median. Mode is missing. Yeah, there we go. Okay. And that's one of those tricky things. The 50% here represents the 50, like the quantile point. So the value at the quantile point 50, 50% percentile, however you're talking about it, this is that value. So that is effectively the median. Someone said the mode is missing. That's absolutely true. And something that builds from that is like some of this data, although it's represented as a number, like female's represented as a number, 0 or 1. You can calculate the average of a bunch of zeros and ones, which can communicate some information to you. But in truth, it's a nominal variable. And other variables that you may add later might have like multiple categories. In which case you would want like to include like it wouldn't include those non-numeric variables. So like mode is indicated differently, and we'll come back to that here in a second. But like that might be something that's missing if we're looking at genuinely categorical data. Does Python read true false values as numeric for averages? That's a great question. I do not know off the top of my head. I suspect it does not. I suspect it treats it as it looks for genuine numeric variables, and then booleans, which are in the background represented as zeros and ones. It probably doesn't include those by default if you have to like later on I have a good example that shows you like how to include categorical variables, and I think true false in the language of pandas, the logic of pandas will count it as a categorical nominal thing. But yeah, that's a good question. We can look into it. So let's keep going. Question mark, df describe, shift enter. Again, like what are my options? I have different things for like percentiles, none. None just means like we haven't given it a default in this case. Include none, exclude none. So it's going to go with whatever its default operations are, but we can override it. So we've got percentiles. So the 50 percentile mark does represent the median, but and 25 and 75 is really common for like interquartile ranges, if that's what you're into, if that's your vibe. But what if you're doing exploratory stuff because you want to possibly shave off extreme values? Like if you're looking at a range of salary income, like household income or whatever, and you want to trim off like the bottom 2.5% and the top 2.5%. Or see where those markers are and see like, oh wow, those are just astronomical. So I want to shave that out of my data to regularize it a little bit. I don't know. Maybe you guys don't ever do that with your data. I don't want to be too prescriptive on your statistical approaches. So we can expand. If I scroll down a little bit further, DF describe, like we can start to incorporate that. So percentiles, my arbitrary example, I just wrote out a big old list. A list is square brackets and then stuff. Stuff, comma, stuff, comma, stuff, so on and so forth. Shift, enter, and now I've modified my descriptive output. This is probably the last important meta piece of information about this code file because we're down to about 40 minutes, which I think we'll get through a decent amount of the remaining code for sure. But df.describe percentiles, this is a practice exercise. This is where I'm telling you, like, hey, you should give it a shot. You should try this. You should try something. Sometimes it's unguided, sometimes it is guided. But in this case, the format I tend to use is like, all right, here you go. Replace these question marks with your numbers. What numbers do you want to try? And if you wanted to, you could add more. You could do comma and then add like a fourth number, a fifth number. You could expand it, go down to one, up to whatever. Throughout the remainder of the code file, there's going to be several points where in the comments I say practice in all caps. Hopefully these serve as like little guided checks. They're not tricks, they're not like gotchas. They're meant to be an opportunity for you to practice, like not just reading my code, but then modifying it to do a similar thing, as like a little test of knowledge. Do spaces matter in the code? Oh, that's an amazing question. No, no, for the most part. So I could do like let me just write out an example. So I could do x equals square bracket 1 comma 2 comma 3 comma 4 comma 5. This and like where I add all of these spaces in, Python is extremely forgiving and it doesn't care. Like I include lots of spaces in my sample code because I want it to be readable to you all. Because like the hardest thing with coding in a new language is like, where do I put the comma? Do I do this? Do I do that? What's the syntax? So I try to like expand it out because Python is very forgiving to spaces. And then like if you're used to other coding languages, you might put a semicolon at the end of a line. Python doesn't do that, doesn't need it. It's just line break, new code, line break, code next. Like whenever you have a line break, it works. The times when that doesn't happen is when you have an incomplete command. So, for example, PD read CSV parentheses. If I could hit enter a bunch of times. This open parentheses is an incomplete command. Python will then look to every new line or wherever, as far as it has to, until it finds the closing element. So then I could literally put in like, please don't format your code this way. This is an insane way to do it, but it's an illustrative example. So like technically this is still just PD read CSV. And the only reason like the line breaks are acceptable in this case is because we have an incomplete, like open parentheses requires a closed parentheses. Open bracket requires a closed bracket. And you can, and to make your code more readable, that's extremely common. Let me like, so this is particularly easy to read, but if we have like a super long line of code, we can do things like and hit enter, and it will do some auto indentions, and then comma, hit enter. Oh, sorry. Let me move back my cursor back and move that parentheses down. So hit enter after that comma, index col equals 0. So you can like format your code in a way that's a little bit denser. That's a common convention, but to answer your question in short, white space, the blank spaces, white spaces as they're called in Python, like doesn't really matter. Doesn't affect most things in most cases. I'm gonna move on now. Part 3 is a lot of words. Okay, part 3 is where like I am a little bit more explicit and I give some examples of like, okay, let's break down again as a recap, importing modules and functions. I'm not going to talk to you all the way through this. The core is you're going to see 2 different examples. If I scroll down to importing modules and functions in practice, we don't need to run this code. We're going to go lightning fast through part 3. This is the version we used. Import a module as an abbreviation, use that abbreviation, dot function. Okay. Another example that you're going to see when you're out there in the wild, digging up examples of code of other people doing similar things to what you want to do. If you don't need the entire pandas module and you just want a single function, you can isolate that. So you can say from pandas, from a module, import just one thing. And then you could use that thing in isolation as a standalone functional object in that regard. You'll see both examples, and that's what like That's all of what part 3 is talking about, is like how to understand these different things you're going to see out there in the wild. There's not much to like for us to interact with and practice here, but this is like the idea behind part 3. If I keep scrolling down to like functions and methods, so like functions and methods in practice, like we cover it here. Functions versus methods. I'm going to go down to using methods in practice. I'm going to click the plus sign at the top. Here's the highlight. Function stands by itself. A function can do whatever in isolation. Now it might require like the module, so like module name and then dot function if it comes from another tool, but it still stands on its own. So in our example, that would be like PD function for a pandas function, and then we put something inside the function. This is separate from the alternative that we've been seeing a lot of, which are methods, which basically have the same structure as a function. The difference is like I have an object already, and what I shouldn't use the word like obj. We'll stick to that. I have an object, like object equals 7. I have an object, and then that object has special abilities, powers, operations, classes, whatever you want to call them, methods, and you access those by dot, and then you can access the subroutines of that object. And I just want to spell it out. So like we've been using df dot describe. So the df object, the describe method, which produces summary statistics of the df object. Every object has these types of things in various ways, even the simple stuff. So an example of x equals oranges, I'm going to do alt enter, and I'm going to do x, then I'll do shift enter. So x is oranges, lowercase letters, but x has a method called capitalize. The df object, our data frame, it probably doesn't. It probably like capitalize is specialized to a specific type of object. X is a string type of object. I mean, we know this just as a matter of fact up here. We could use that tab trick to access the rest of them. But in this case, X dot, and then the method of interest. Let me do shift enter. So now it's capital O. So capital O oranges. Or I could do swap case, and it makes it all caps. So that's like kind of the distinction between functions and methods. Again, I've written all this out. That way you can like take your time to read through it, read through the examples. The one that I want to use right now, though, like the last part of part 3, that really matters for the next stage of working with our data, is like accessing contents. So these methods are like operations. These functions are operations that do a thing, calculate a thing, transform stuff. But what if our object represents a container of other objects or other values, and we just want to access components of it? That's where, if I scroll way down, this is how you know I'm getting serious. Then I'm going to take a breath and look. I think I see the chat flashing around. Capital X is my new object, and I'm going to assign it the values of like square brackets. So this is my list, and it's a list of words: cat, dog, bananas, oranges, coffee, tea. Now, this is a silly example, but the point is going to be very clear when we work with our data object here in a second. So I'm going to do shift enter. So now I have X, and X is a container of stuff. It's a big list of words. But what if I don't want all the words all the time? What if I just want one of those words? So there's a variety of ways to do that. Different objects do it in different ways. But in this case, like I will just use square brackets next to X. So I have my object, and then I have square brackets following that. And then inside the brackets, I identify the things I want. And in this case, I'm just going to put the number 0 because I just want the 0th item or the first item. Shift enter, and I get cat. Easy peasy. Shift enter again for X2. So now I see, remember, Python starts counting at 0. So X0 just gave me cat. X2 just gave me bananas. And we can make it more complicated. We can do ranges of things. So 2 to 5, shift enter, it can give me a range from the second object up until the like marker point for the fifth object, which really just means items 2, 3, and 4. That's a whole nother thing in Python on how to deal with lists. The point though is I used my square brackets and then I used like my indicators. So 2 colon, which is range, 2 to 5. 2 ranged to 5. How do packages in R compared to modules? They're the exact same. So, like, if you in R, you need to install a package, tidyverse. So then it's installed on your computer and it's set up. And then you do library parentheses tidyverse. That's the same thing we're doing with pandas here. So pandas is pre-installed with Anaconda. So we didn't go through the installation step of installing a package, but everything else is the same. Pandas is a third-party package or module. I think they're formally called modules in Python. I call them packages when I'm like talking too fast. But it's a third-party thing that we're bringing in and then making use of in this environment. Great question. Can we see what objects are available to perform functions on? Are list vectors more like arrays? Short answer, can you see the objects you have created? That's a weakness of Jupyter. There is a way to programmatically get everything to display, but it's going to show you a mountain of other pieces of metadata that will overwhelm all of us today. So there are some ways to see like what are my objects, but in the Jupyter environment, that's just not a well-designed feature. There are other Python editors, other Python environments that do that. So like when you say x equals 3 in RStudio will give you like a little pane that says like, hey, here are all of the objects and all of the functions that you've made. Jupyter Notebooks doesn't have that, so you do just kind of need to keep track of the things you're working with. Um, Also, like Python lends itself well to like functional arrangements of data. So like eventually it starts to be easier to generalize everything once you start to wrap your mind around all the ins and outs. But if you like that RStudio environment, there is an editor called Spider. Spider looks exactly like RStudio, where you have your code, you have your console output, you have your environment pane. Like it's just not as popular, it's not as widely used, and it's not as ubiquitous. So like that's why I'm not teaching it. But it does have that functionality if you really do crave that. Are lists vectors? There's like vectors, there's matrices, like one-dimensional matrices, and arrays. It's easiest to think of a list as a list, and a list doesn't have to be numbers, and it doesn't have to be uh, like it could be a mismatch of like different types of data. When you start saying the word array or the word vector, then you're starting to imply that, like in Python, I'm just telling you to be cautious. Like connotatively, yeah, we could call them anything we want. Vectors, arrays, lists, they're largely the same. They're ordered. Uh, the the challenge is once you start using the more advanced math packages like NumPy or any of the machine learning things, those words start to carry like proper noun meaning. So like an array must be a fixed with integer type, da 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 da. Like it gets very technical. So I'm saying that to be a little bit cautious, but yeah, lists, vectors, arrays. It is a sequence of information that has a set length. We can make that length longer dynamically. That's one of the things that lists do that makes it not quite the same as like vectors and arrays in a mathematics sense. Good question. Lines 3 to 4 seems like, oh, okay. Yeah, let me explain that. So I said items 2 to 5. So up here, like let's look up here. I'm going to change the color to, I don't know, purple. So the way Python counting works when you're just counting items from a list, you have like 0, 1, 2, 3, 4, 5. So I said 2:5, so 2 to 5. So we go 0, 1, 2. So this is where it starts. And then 3, 4, 5. And it does not include the thing after 5. So it goes to wherever these little marker points are, like the positional points with respect to the list of the array. That's a common like struggle that people have with like indexing arrays and doing stuff in Python. So that's how the logic of that works out is like you're going to the second position and then you include everything up to the fifth position, but not the value that like immediately follows that fifth positional marker. Hopefully that clarified. Now, like I think R does it like different tools do different things differently. This is also why I always encourage people like take little tiny examples like what I've made and just test them a bunch and just like see what the ranges do, see like what numbers do and do not work, and just make sure that you have a good intuition for like what the particular tools are doing. That's a great question. Right, absolutely. It's from position 2 up to position 5, but not including the value at that last step. And also like it's important to remember that it starts counting at 0 and not at 1. R starts counting at 1. And that's a struggle for me because I use both of them interchangeably and I have to remember which I'm doing. So like we've been working on the whole data set, the DF object, the big table of data. Well, you don't always want to do that, especially I suspect some of you work with data sets that are more than 5 variables, like maybe 5,000 variables if you've collected huge amounts of like CDC or census data, or you've merged a lot of data files together and you have just an astronomical number of variables. We got to get some subsets. So let's practice on getting subsets by columns and by rows. To do that, so like here, we've got DF object in part 4, shift enter. Okay, good sanity check. My data still exists. Scroll down a little bit further, square brackets. This is where that last little piece from part 3 comes into play. Square brackets, and then we're not going to use numbers per se. We're just going to specifically identify the name of the column as a string. And if you don't remember what they are, like capitalization matters. So capital D, capital L, ride underscore alk underscore driver. Either way, like you could just copy paste that, by the way, like, and control C, double click on that, control V, voila, shift enter. And now I just have a single column of data. And I could swap that out, like swap it out with like female, or change it to one of the other variables like ride underscore alk underscore driver, and just see like, can we narrow it down to the single column that we want? And we're going to do multiple columns here in a second. And I'm going to start speeding up, by the way, because we're down to about 20 minutes and I don't want to get too lost in the weeds. So I'm going to keep going. If you remember, we had df magic sauce dot describe. We can now expand that. So we could do df square brackets. So this whole thing is selecting just the column we want. And then we expand it the same way using the same method, describe after the dot. So shift, enter, and now I just have the descriptive statistics for just that column. Also, when you're working on a single column rather than a table, there are more methods available to you. By the way, a single column, the question came up, are these lists? Are these arrays? Are they vectors? R will often call them vectors. In the language of pandas, a column or a single set, a single list, a single array of data is referred to as a series. It's just the proper noun they use. So like if you see that word come up, that's all it means. So like we've selected a series or a column from our data, and now we have other options. We could just like, instead of getting all the descriptives, we could do dfh4 mean parentheses, shift enter. And then like, yeah, let's check it real quick. Yep, mean 16 point da 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 da. All right, cool. So we're getting these values. Spoiler alert, there's a method called median. This is a good chance for you to practice. Practice later. Like we're going to keep bustling through the code at this point. And we can look like, you don't need to do this. Just watch me. Pandas, methods. Let me just go to their website. And if I scroll down far enough, here are the attributes. This is the giant list of stuff. Ooh, here are the methods. Here's the giant list of methods. I'm going to go faster than you can read on purpose because I don't want you to dwell on this. Like, you can do tons of different things to these series, to data frames. You can do logical checks. You can do cumulative sums. You can do like all sorts of replace missing values. You could do merges and joins. All of this is available. Like when I say like read the documentation, I do mean it. Like there's tons of options, and you can always Google like, hey, does pandas have a way to remove missing values? And then like, oh, oh, hey, look at that. There's a function or a method that does what I was thinking. And I just typed it in natural language in that regard. And that's from the official documentation. So I'm going to go back to my code now that I've shown that. And like, we're just going to run through this. So df square brackets std, standard deviation, minimum value. Here's a practice. Like, can you write the code to get the maximum value so that we know the full range of our data? And then just like before, like we could do quantiles and specify an individual number. We could do quantiles and specify an array of numbers, a list of numbers. So we could use square brackets again and give a list of items. So 0.25, 0.75 if we're interested in like interquartile range. Let me do shift enter on that. And then I just get like simple little outputs, 0.25, the value from the age variable, age 4, the value at that quantile mark, that percentile mark, is 15. And the value is 17 at the 75% mark. Now, what if, now I asked this question earlier, like what is missing from describe? Some of you said a variety of different options. I've heard like, I've been teaching Python workshops for a bit now. The examples can get pretty wild. Like skew and kurtosis are probably two that jump out right away to me from a statistics point of view. Now, pandas can do skew and kurtosis. That's not the point here. But what I want to highlight is like you can take the data from pandas and take that data and import it into another function from a totally unrelated module. So let me do that real quick. Let me like just demonstrate that. There's a package called SciPy, Scientific Python. It's an amazing package. Like lots of statistical tests and measures are available in this package. So I'm going to import it. I'm going to import scipy.stats as the abbreviation stats because I know stats has like functions like skew and kurtosis. Those are the two that I want to mess around with. So I run that line, shift enter. So now I've imported scipy.stats, scroll down a little bit, stats.skew. So again, just like pandas, pd dot something. This module is called stats now. Stats.skew, skew is my function. And inside of it, I put my data. Okay, so like we've taken our data frame object, we've subset it, we chose the column we want, and then we put that as one whole unit inside of another function. So you can mix and match things in that regard. Shift, enter. Ooh, not a number. I wonder what that means. Well, I know what that means. If you remember, like from our earlier explorations, there's missing values in our data. In some calculations, like you can't calculate the average of a data set and include the missing values. You have to like remove those just arithmetically. So that's one of those things you have to keep in mind. Like, oh, okay, so it's not like the function didn't produce an error; it resulted in something clear. So I need to deal with like, if I read the documentation, there's stats.skew, nan policy, omit. This comes from the documentation. So now if I do shift enter, now I get this complicated output. So this is one approach. Stats.skew, and I put my stuff inside. I put my data, and then I put an option saying like, hey, ignore missing values. Just drop them temporarily for the purposes of this calculation. And then we get a result. The next thing that I want to point out is like for any one way you can think to do something in Python, there's almost always another way you can achieve the same outcome. Choose the one that makes the most sense to you or fits your needs. So for example, I'm going to scroll down, stats.skew. I put my data inside, but in this case, I know of another method. I know like df square brackets h4, so I've chosen my data, and then there's a method called drop na, which means drop na, drop null values, just remove them temporarily. We haven't like updated our data frame object, but for a temporary purpose, truncate the data to just the valid observations. And then that becomes our whole piece of data inside of skew. Shift, enter, and now I can see both of these options, negative 0.08, something, something, something. Like the values are the same. So we're getting the outputs in two different ways using a wholly new module. And then the rest of this example goes on to talk about like, all right, here's some practice. Try it again with grade, drop nah. Here's a kurtosis example. It's going to give that same error. Shift enter. Nan, we're still missing some values, so we still have to either drop them or do that in a policy omit option. Either one. We can approach that. This is one of those examples. Someone asked something that made me think of this, like shift enter. When you're talking about kurtosis, what is the correct value for, or not correct, but what is the value that represents a normal distribution in kurtosis? This is where I would usually pause and trick people up. There's a couple different ways to do that. What is the assumption that the developers of this module made? Do they think kurtosis is 0? Like a normal distribution is at 0, or is a normal distribution at 3? Which one? Like the answer kind of depends on what discipline you're in. The answer from a technical point of view is read the documentation. Stats.kurtosis, question mark, shift enter. And then I see like, oh, there's an option called Fisher. And if I read that, it tells you like, these are the assumptions we made. And if I keep scrolling down, I can see like, the Fisher option, if true, uses this definition. If false, uses a different definition. It's important for you to realize like different analytic methodologies have different approaches, and they're usually included in the development of these tools, but you have to read the notes to make sure that you are getting the one you expect. Scrolling down a little bit further, we've got some good practice. Oh, by the way, like DF does have skew and kurtosis. Like it's an arbitrary example where I'm showing you how to use another module or another package to calculate data that we generated in a pandas environment. Okay. Last couple things I want to point out, and then I'm going to look back at the chat, and then we'll keep on going. This whole section here, don't pay attention to the details, okay? What I'm trying to do here, just run this cell. It's going to create a new df temp object, and just hit shift enter twice. All it did, like there's some complexity there. Feel free to read it and decode it, but I don't want to bog us down in that. But what I've done here is like, I've transformed ride alcohol to like ride, and then yes, no. So I've replaced yeses and nos, males and females. I've replaced the numeric indicators with a label. I did that just to be artificial in this case, but it might be a real thing where the data you import comes labeled as strings, and you might need to do the reverse, or not at all. Doesn't matter. The point is, assume that we have a data set that has categorical variables. If I scroll down a little bit further, I expand a little bit because I just want to show you how to get some descriptive statistics for that as well. So now we have a new object called dftemp.describe. It doesn't include any of those things. We have, by default, it only looks at numbers. If it's not a number, it doesn't care. So df describe include equals all. I do shift enter. Now it includes those categorical variables. And now we start to see like, okay, so for this first set here, it's giving us a bunch of nans, not a number. Like it's not able to calculate those metrics. But let's just take one example for like gender is the category I made. The way we read this set of descriptives is like the unique number of factor levels is 2. Male, female, in this case. In this case, top is equivalent to mode. So what is the most frequent category? Female. Females are the most represented categorical label. And then frequency is just the number of times female appears in the data set. Which, like, that's not the best descriptive statistics. We kind of want to further break down. But this is like where we can start to decode and understand what's going on with our categorical variables when we have them. And if I scroll down, by the way, we can df temp square brackets value counts, shift enter, and like value counts is one of those methods, one of those tools to get a listed count of like the frequency of every category. We could also put something inside the parentheses of value counts. Normalize equals true, shift enter, and now we get proportional values because sometimes frequencies don't, like they're not that useful. You want to understand what is the percentage breakdown of different groups within my data set. We just bulldoze through that real fast. The next thing that we're going to do for the last few minutes is talk about subsetting rows, and then I'll very quickly show like crosstabs and cross tabulations as we like round out for the day, but you'll mostly do that on your own. Primary benefits of Python over R. Python has a bigger development community. It has a lot more people working on machine learning and like those really advanced analytics. More of those packages and modules and developments are happening in Python than R for those types of things. R is much better, and well, better maybe doesn't matter. It's easier. Python is much, or not Python, R is much easier at doing statistics. If you're a traditional statistician, then like R is a much easier tool to use right out the gate. The other thing that like Python then, because it's so generalized and so popular, if you want to do other things like web scraping, in my experience, is much easier in Python than it is in R. So by that same virtue, you might, if you're doing data collection where you do web scraping to collect your data and then analyze it and then write it to an SQL database, depending on what tools you're using, Python might be the better comprehensive tool. But that being said, because it's not specialized the way R is, it's also a steeper learning curve for a lot of those things. In Python, R, NA, and NAND differentiated. There's null, NULL, all caps. Then there's not a number, which is a, like there's a variety of ways that missing values are encoded in Python. That's a pretty deep technical question, and I don't know that I fully know the answer to it. But there are different ways to encode different types of missing values. Pandas looks at all of them and acknowledges it's missing. Like, and when you ask questions like how many missing values are there, it counts up all the different types of missing values equally. So it does a good job of collating that stuff. So there are distinctions in different types of missing data, but Pandas treats them comprehensively in the same way. Is there a way to identify how many missing values are in your data set for a given variable? Yes, there is. I'll cover that here in a second. What are the primary benefits of R over Python? That was covered. How were we able to find the mean quantiles of df.age if there are NAS also described in? Yeah, right. Describe doesn't show NA values. Pandas. So, like when we did that thing with SciPy, like stats.kurtosis parentheses data, we had to be explicit. We had to say remove the missing values. Pandas, when you do like pandas square brackets age dot mean, the pandas method inside the parentheses for mean, it automatically removes those missing values. So like some functions will automatically do that, others will not. That's just one of those things that you learn along the way. Can we export the output from descriptive statistics in Word or Excel? Absolutely. That is like whatever part last is in the workshop code file. Part 5, select by rows. So this is a good opportunity. It's not too complex, but it's a good opportunity for you to practice. So df is our data. Okay, easy peasy. df.location square brackets. So df.loc, this is the core of how you choose multiple columns and multiple rows and subset your data. So df.loc, in the square brackets, it follows a very common notation of rows, comma, columns. Anything before this comma, no matter how complex it is your selection of rows. Anything after it is your selection of columns. Okay? So in this case, the colon simply means, give me everything. So shift enter, this is just saying, give me the female column. If I expand it out, again, after this comma, all of this is my selector for columns. So I have another set of square brackets in a list of female smoke driver's license. Shift enter. So now I've subset by columns. Keep going. I start to do the exact same thing with numbers, lists of numbers, and I combine them, and this is where things get a little bit different. df.loc, a set of numbers, whatever they are. So in this case, it's a range, 1 to 15. comma, columns. Shift enter. So now I've taken my data set of 13,000 samples and I've truncated it to 3 columns and just 15 observations. Okay. So this whole section, like, it's worth, like, even after today, go through this multiple times because this is the crux of like selecting and subsetting data, which is probably what a lot of you do at the beginning of your research. So like, but everything we've been doing builds up to this in terms of understanding the method, the square brackets, getting the syntax right. Scroll down, and then I've got just lots of practice exercises for you written out. The next thing that I want to do though is like conditional subsetting because you don't always know exactly what you want. So here's some descriptive information. I'm going to scroll down a little bit further. Let me take the column df age square brackets. Now I can use an operator less than 16. If I do shift enter, it doesn't return the values. It says like, hey, true, false. For any given observation, was this condition met? Whatever it happens to be. It could be greater than, equal to, blah, blah, blah. And I describe them up here, like a variety of them. But now we can put that into the same location tool. So df.loc, I have my conditional statement. So like, hey, give me all of the true, false responses for age, where age is less than 16. And that is my rows selector because it comes before the comma. And then colon, because I just want all the columns, shift, enter, and then voila. It's worth noting 1, 13, da, 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 like it still goes up to like the row labels are still the same, but the total number of rows captured is right here, this 4,308. So we've trimmed out roughly 2/3 of our data. And if I scroll down, you can do things with like, let's drop all the missing values. So df h4 not missing. If I do shift enter on that, it says like, yep, that one's not missing. That one's not missing. False. It failed the test. So this method of like not in A or not null, not missing, like we can use that to then drop all of the missing values accordingly. Someone asked, how do we get the number of like missing values? Just watch this. df dot is in a parentheses, shift enter. I could get a table-wise, like true false statement of every single thing. By the way, this object looks like a data frame. I can extend that with dot describe, shift enter. And now I can see like from that table that was just a bunch of true falses, missing or not. And we can see like, well, right alcohol only had one unique variable, and it was false. False is in response to the question, is NA? So like it's complete. It has a complete set of observations. These other ones that have twos, that means there were some trues and falses. And this is a way of like getting at like the number of missing values that are represented in any given column. And it's all from like assembling these methods and chaining them together. The last thing that I'll point out here is df.loc, and I know I'm going super fast, folks. Square brackets, everything before this comma is the rows. So all of this here, you can chain multiple conditions together. So I could say, I only want the rows where age is less than 16. And I only want the rows where ride driver is equivalent to 1. And I only want rows where age is not missing. And I can chain all of this together as my rows statement. Shift enter, and then I've narrowed it down to that particular data set. Now, in the language of objects, you can make this a little bit easier to read. You could do something like condition 1, condition 2, condition 3 equals all of the things you describe. And then you could put those conditions into the same syntax. Ideally, like that it's just a more succinct way of writing, which might help keep things more manageable in your mind. But it's just an example. This produces the exact same outcome as above. We're 2 minutes over. The last section, I'll just describe this. I won't run the code until I have a chance to answer questions for people who do need to blitz. Part 6, crosstabs and chi-squareds. This walks you through step by step of like, okay, use the pandas module to create crosstabs, cross tabulations, or contingency tables is what they're sometimes called. And that's what all of this code does. It gives you these examples and builds up and up and up and up. And there's some practice exercises. And then, once again, we rely on SciPy stats. We can do chi-squared independence tests. All of this, all of part 6 just builds off of that using the pandas data to do crosstabs, chi-squareds. You can run through it line by line. And then the very last thing, this was a question somebody asked, save your data. So for all of these things, we can create these objects, these data frame objects, and then like this whole block here, that is the entirety of part 6 is like do a crosstab, produce a gigantic cross tabulation. Once you have these tables, let me just run this real quick. Shift enter. So new df, shift enter, like, okay, cool. Here's my data. New crosstab, shift enter, like here's my cross tabulated normalized proportion data with margin counts. Both of these are data frames essentially, and I can then run these commands, and I'll run them right now. I'll do shift enter, shift enter. So now the very last thing that happened was we did all of this writing, like we exported new df to CSV, and we told it what the file name was going to be. And then we repeated that for all of the files. And now you can see those files are over here in my directory. And in this case, let me click I'll open File Explorer, view details. So on my computer, in my downloads folder, let me go back to drawing. Oh, no, I don't want that. I want, doesn't matter. Over here, you can see all of the exports in my downloads folder on my computer. So I've successfully used Python, opened some data, select some rows, select some columns, do a thing, do whatever. And then now I've exported that in a way that I can use going forward. Whew, okay. We went from like second gear to sixth gear all of a sudden there at the end because I know we ran out of time, but the important stuff was all at the beginning. So we definitely got that. I'm going to take a breath. Thank you all for coming, by the way. I hope to see a lot of you next week.